Epidemiology in the Dock, Part 6, the SIR and SEIR models. We've seen that the SI model has exponential and no escape built in, regardless of the population, distribution, circumstances or size. But what about SIR and SEIR? Note to censors we use only government data. If you have a problem with the results, speak to the government. We left off with the SI model. You're either susceptible or infected, infectious forever, and its growth curve is indistinguishable from exponential on the chart until close to peak, when it finally diverges and then crashes at beyond exponential rates of decline. Note that it's not that it slows down as the contagion comes to a close, quite the opposite. The decline accelerates as the last pockets of uninfected are swept up, and this is very much a function of the 1 over x style of the model, not of any real-world phenomenon. Now we're going to take a look at the SIR model, illustrated in Wikipedia as shown, with the fat decline which got us interested as a possible explanation of the fat declines in our otherwise normal curves. The SIR model is defined thus in Wiki. ds by dt equals minus bsi over n, di by dt equals bsi over n minus gi, dr by dt equals gi, where SIR are susceptible, infected and infectious and recovered, and b equals a growth accelerator constant, n is the total population, s plus I plus r, and g equals gamma is 1 over the disease duration. Recall that this merely translates to today's change in s is minus bsi over n, today's change in I equals bsi over n minus gi, today's change in r equals gi. B is just a constant, an accelerator, so we can simplify our model by setting b equals 1 as a special case and ignoring it. To see what we learn, we can then extend to other b if we need to. So that simplifies things to today's change in s equals minus si over n, today's change in I equals si over n minus gi, and today's change in r equals gi. And we've only really got two things here, si over n and gi. So what do they look like? Let's take gi first. G is 1 over the duration of the disease. What they're saying is the number of people recovering today is a fraction of the infected people. Fine. But what kind of fraction? Using the duration, e.g. 10 days, then G equals 1 over 10. But why not rephrase it simply as recovered today equals infected divided by 10? Now something should strike you about that. It says that no matter what the shape of the curve, 1/10 for a 10-day average disease duration of the people infected get better. So what if it looks like this? 10 people infected every day. 10, 10, 10, 10, 10, 10 for a total of 10, 20, 30, 40, 50 infected. Then with 10, 10, 10, 10, 10 daily and 10, 20, 30, 40, 50 total infected, then the model says that 0, 1, 2, 3, 4 people recover. Sort of. We calculate today's change off yesterday's totals. In fact, if we do it properly step by step, day 0, 10 infected, none recovered, day 1, 10 new infected, recovered, 1/10 of yesterday equals 1, total infected for the day. Day 1 is 10 plus 10 minus 1 is 19. Day 2 with day 1, 19 infected, day 2, 10 new infected. Recovered, 1/10 of yesterday, 19 equals 1.9, not the 2 of 20. Total infected for day 2 is 19 plus 10 minus 1.9 is 27.1. Day 3, 27.1 infected, 10 new infected, recovered, 1/10 of 27.1 is 2.71. Total infected for day 3, 27.1 plus 10 minus 2.71 equals 34.39. Yes, it's messy, I know. Day 4, almost done. Day 3, 34.39, day 3, 10 new infected, day 4, 10 new infected, recovered, 1/10 of yesterday, 34.39 is 3.439, total infected, 34.39 plus 10 minus 3.439 is 40.951. It's just arithmetic. The point is that our simple 10, 10, 10, 10, 10, 10, 20, 30, 40, 50 actually looks like 10, 10, 10, 10, 10, 10, 19, 27, 34, 41. Now compare the two series of totals, 10, 20, 30, 40, 50 and 10, 19, 27, 34, 41. Total infected, a drop of 0.1369, and that's quite a difference, down by a quarter. And that's just by day 4, 0 based. But wait a minute. We're on day 4, 4 days after the first miraculous infection of 10 to make our lives a bit easier for the purpose of explanation. How long is the disease supposed to last before you recover? 10 days. 4 days in and no one is supposed to have recovered. But the model says sure, 25% have already recovered. 9 of the 40 infected up to yesterday, and yes, 22.5%. And we did a simple constant rate of 10 new infected a day. What about oh gosh's exponential virus, 1, 2, 4, 8, 16, 4, 1, 3, 7, 15, 31 total infected, which is 2 to the n-1, as tech heads will recognize. We're not using the model specifically, just looking at this 1/10 recover element for a nominal exponential virus. So, day 0, 1 new, recovered 0, total 1. Day 1, 2 new, recovered 0.1, total 2.9. Day 2, 4 new, recovered 2.29, total 6.6. Day 3 that would be, 8 new, recovered 0.66, total 14. Day 4, 16 new, recovered 1.39, total 28.6. And no, you don't need to follow that, I just needed to work it out. So we had 1, 2, 4, 8, 16 new for 1, 3, 7, 15, 31 total infected, and by day 4, according to the 1/10 recovered model, we have 1, 2.9, 6.61, 13.9, 28.5, which is actually a lot closer to the raw doubling without recovery, but technically no one's supposed to have recovered. I feel like a child that only got 3.8 sweets instead of the 4 they were promised, but ma. However, astonishingly, I think we're about to find the source of the magical fat behind in the SEIR charts. The fat behind that got me interested, thinking they might be onto something. Or on something, more like. Let's do the tail, so we're going to reverse it and we'll say that we had 31 infected by peak, recorded as infected, per the 1, 2, 4, 8, 16 on the way up, and we'll now do 8, 4, 2, 1 on the way down. And yes, we could use 28.5541, but it's not going to change our observational inquiry. This is live research. Yep, I'm working through this even as I write the slides. Fine, I'll use 28.5541. No Sybil, doing it now, Sybil. So, at the end of day 4, we have 28.6 infected. Day 5, 8 new, recovered 2.9, total 33.7. Day 6, 4 new, recovered 3.4, total 34.3. Day 7, 2 new, recovered 3.4, total 32.9. Day 8, 1 new, recovered 3.3, total 30.6. Day 9, 0 new, recovered 3.1, total 27.5. Now, remind me again how long the disease takes to run its course. 10 days. So on day 9, how many people are supposed to have recovered? None. How many does this SEIR 1/10 a day say have recovered? 18. How many cases were there? 1 plus 2 plus 4 plus 8 plus 16 plus 8 plus 4 plus 2 plus 1 is 46. So nearly half, or 40%, have recovered, and not one was supposed to. Doesn't that seem a little off? The reason is simple. They used utterly the wrong formula for their recovered adjustment, and anyone familiar with our lagging deaths to cases should recognize it. They said 10 days infected, fine, take a 10th off each day, close enough. We say, wait, lag, 10 days, and that's when they recover. Their method has a uniform chance of recovery every day, 1/10, which is unrealistic if a typical recovery would be 10 days. This really is quite fundamental, and it's going to look very familiar. You have the flu, most people take 2 weeks to get over it, say. Let's have 140 people with the flu, kazam, right now. Would you expect 10 people each day to suddenly realize, wow, my flu has gone? Or would you expect most people to have to suffer the 2 weeks of flu, more or less, give or take a day or two? Now, does that sound familiar? Most people, on average, taking 14 days to get over the flu, close enough, give or take a day or two, with a bit of variance, like a normal distribution. Which that is, upside down, If it takes 10 days nominally to recover, is it realistic to say that means 1/10 will be recovered tomorrow even though they just got it today? No. It's the whole point of normal distributions and standard deviations. If the average pregnancy is 9 months, does that mean that 1/9 of pregnancies will only last 1 month and a healthy baby will be born? And 1/9 of pregnancies will last only 2 months, and a healthy baby will be born. And if the average is 9 months, where's the 10, 11, 12 to 17-month pregnancies to balance the 1, 2, 3-month pregnancies? They chose completely the wrong notation or formula, and it's like taking Viagra versus the pill. Sure, it's a pill, but that hardly makes it a fit-for-purpose pill. Or vitamin C and saying that's the scientific way to not get pregnant. Yeah, and you do know what's going to be in those vaccines, don't you? Just saying. The point is, we use this all the time, and even when you implement their model, you use this. That cases today equals new cases today plus the cases of yesterday. Time notation. Cases at time t equals new cases at time t plus the cases at t minus 1. Yesterday. And yes, normally those would be subscript. Want to see the real death rate? See if they stuffed the figures? Simple death rate equals reported deaths over reported cases, totals. D.T over C.T in our usual nomenclature. In time nomenclature, it's dt over ct, today's deaths over today's cases, in totals. But you're not supposed to die the day you enter hospital. So really we'd expect you to last, what, a week, 2? Germany and Austria have peak deaths 2 weeks after peak cases. So yes, 14 days seems about right. So what happens if we divide deaths today into cases from 2 weeks ago when the dead people got sick? In the UK, especially in the early days, rising curve, 2 weeks ago not many cases, but hey, a lot of people sure managed to die regardless. You get close to 100% death rate. In Spain you get a 300% death rate. Yep, more people died of Covid-19 than had Covid-19. But there's nothing dodgy about those figures. The point is, this is trivial. If you have 50 cases today, you wait, tick-tock a day, tick-tock 10 days, and hey, now they've recovered, using our 10-day disease scenario. And of course, joys of computers, which epidemiologists do have, lagging figures is simple, just take the value 10 rows back. Or in time notation, the change in recovered today is the change in infected of 10 days ago. T stuff in subscript, and did you know that T stuff is very volatile? I not divide by 10, hey fine 1/10 each day, but at least do it properly and say 10 days later you're recovered. And if you want to do it even more properly, say on average. It's 10 days later, then you've recovered. And add a stochastic or random element. Here we have the prime epidemiological model, and it can't be bothered even to express the basics right. The whole point of the differential model is that it's supposed to express subtleties that e.g. logistic or normal distributions can't. Well, the only subtlety it's expressed is that a 16-year-old would be marked down for getting that wrong on a math paper. Height is normally distributed with a mean height for men of 5 foot 10 inches. The standard deviation is 3. What percentage of men would you expect to find between 5 foot 7 and 6 foot 1? 10%, because there'll be the same number of men at each height from 1 inch to 70 inches. And how many 1 inch men do you know, ladies? Tall, I mean. Not many. If this was O or A-level maths, the SEIR model would be marked down, yet another fail, wrong formula, on top of how many so far. About 5 major flaws, I believe, from memory, and 1 more, dividing instead of delaying. And my apologies, I suddenly realized I could have put this rather more easily and perhaps more powerfully by showing the 2 or 3 styles graphically. So let's do that. Here's the SEIR model of pregnancy, birth, and motherhood. So we have a wonderful New Year's Eve party, goes really well, and in January 27 women discover they're pregnant. Joy! Now pregnancy is observed to be 9 months duration, so SEIR invents a gamma constant 1/9 because it looks sexier or sounds more official than just saying divide by 9. And each month thereafter, 1/9 of pregnant women give birth. So yes, in February, 3 lucky women forego 8 months of pregnancy and deliver beautiful bouncing babies. Dark looks are cast their way by the remaining 24, or maybe not, who knows. March, not 3 lucky women, but 2.67 of the 24 still pregnant women in February now give birth. A fifth of mothers have now avoided the vast part of their pregnancy and get on with their lives. Happy mothers. By month 6, half of the women have now given birth and are happy mothers. The other half console themselves that the early batch are missing out on true motherhood and keep going. Still pregnant, go figure. By month 9, October, January is month 0, blessed joy. It's all over, but only for 2/3 of the pregnant women, now mothers. A third of the women are still very much pregnant according to the SEIR model of pregnancy. By March 2021, 14 months of pregnancy later, 80% of women have at last given birth and become mothers. Joy, but not so much for the remaining 20%. 2 years later, January 2022, and still there's 6% or 1.6 of our 27 women who haven't given birth. Oh boy. Now bear in mind, this is the identical arithmetic used in Covid-19 to manage the time between becoming infected and recovering. 12 days later seems about right. And this is the model that got you into lockdown. Handling delay is handling delay. Would you say this was a reasonable mathematical treatment of modelling the onset of birth from pregnancy? Or put it another way, is this real or nonsense? We generated an alternate form, seen in the same table. Now I'm just a guy not claiming any particular expertise in the matter, but we could do as we did with cases and deaths lag and say, hey, the number of births today is the number of pregnancies reported 9 months ago. Too simplistic? Sure, we could add some variance to that to make it look more normal. So I don't know, which do you think looks more realistic? 1/9 of women giving birth in the first month and 1/9 of the remaining pregnant women each month thereafter? Or the right hand side, everyone gives birth pretty much 9 months later with some variation. Remember, this is the most widely touted official model, far better than logistics, certainly better than the not even mentioned normal. This SEIR model has been mathematically analysed with amazing levels of analysis. Check the Wikipedia entry on compartmental models in epidemiology. I mean, seriously, I can recognise the language, but recognising that it's Greek doesn't help you understand Greek. And that on the left, it's all Greek to me. Yet people clever enough to do that kind of analysis think 1/9 of women giving birth in the first month of pregnancy is a lot more realistic than the old school wait 9 months and allow some variation that most of us consider normal. Gee, someone should create a formula for that. It looks so normal. Farr, again, as noted elsewhere in another video as kindly reported to me by a viewer, he showed that during the smallpox epidemic a plot of the number of deaths per quarter followed a roughly bell-shaped or normal curve, and that recent epidemics of other diseases had followed a similar pattern. Now these charts, as our viewers will recognise, are the disease cases and deaths looking pretty normal, not exponential, for just one of 214 countries, all of which look either like this, the first half still climbing, or the first and second halves, pumped, and none look exponential, straight line on log scales. But that's big picture. We're looking at the delay inside the big picture from onset of infection to recovery. And guess what? When we look at a real-world example, e.g. births, it's totally natural to recognize that nobody gives birth at 9 months, 0 days, 0 hours, 0 minutes, 0.00000 seconds. Some variation is normal. And gee, is it too much to ask that maybe we consider that if the COVID-19 illness from onset infection to recovery takes, say, 12 days, that it's not 12 days, 0 hours, 0 minutes, 0.000 seconds, but roughly, on average, 12 days, with some variation. That's normal. That's all we're showing here, taking it out of context so that the COVID-19 mental illness failure to think once that keyword is mentioned doesn't strike. It really is like hypnotism, isn't it? MK Ultra, who knows? Maybe the mass of the public really are that gullible, naive, or unwilling to think, or maybe it's not their fault. Either way, it's sad. This would be a reasonable model for the expected births given initial pregnancies, wouldn't you say so? Tall orange bar for theoretical or average duration of pregnancy, normal variation. This, however, in no way represents a realistic model of births with 1/9 of people born in the first month after pregnancy and 1/9 of the remaining pregnant women giving birth each month thereafter, so that 2 years later some women still haven't given birth. Yet this is the official SEIR way of treating the duration of the disease. 12 days, 1/12 recover on the first day. Not normal in either sense of the word, but because it's COVID-19, guess what? Some people will try to justify it. People, skilled, intelligent people, have already invested massive amounts of time and effort in analyzing this model, never once noticing that the sickness typically lasts 12 days is not the same as 1/12 of sick people recover each day. Typically, last 12 days, with some variation, is all but the definition of normal. And how do you think the normal distribution got its name? It's normal, but not in SEIR, no sir. And you know what? That's probably a great place to leave this episode. We'll do fact tales another time. And you know, I do know a bar, but that's another story. When we began this story, March 24th, I was already astonished, scared and angry that so much nonsense was being so readily believed without the slightest fact-checking or application of common sense. When we discovered that lockdown in the UK has not changed the trajectory of the virus one iota, sparing not one case, saving not one life, even I was astonished. Locking 66 million people into their home, hey, they chose the term, not me, lockdown, not gentle reminder, let's be sensible, should have made some difference. Instead, at peak, when cases and deaths growth rates should have collapsed, they rose relative to the normal decay, going sideways, massively exaggerating the real virus action because, hey, the virus doesn't report cases and deaths. The government does. That was less astonishing, but still astonishing and inciting indignation. No normal till a vaccine. The agenda revealed. That was astonishing that they'd be so blunt and warn us so quickly, and it made us angry. And yesterday a viewer showed me that Ferguson has now published a paper to show how many cases and lives lockdown has saved. That made me truly astonishingly angry, being the most utterly blatant lie based on a fraudulent model. But nothing experienced so far prepared me for the devastating sense of despair that I feel that I am confronted with science as a mathematician, and I find it to be complete hokum. Snake oil. Exponential when disease contagion is not. Put in a number, that's how many get infected. And want to know how many women give birth 1 month into pregnancy, full normal birth, 1 over the duration of pregnancy equals 1/9 of pregnant women. And some women won't have given birth 2 years later. That isn't science. That doesn't model reality. That isn't even close to being sensible, which is even more tragic when a far simpler and far more sensible variant is already out there and matching bloody well with the data. And the truly frightening thing is that millions of people have looked at those equations and not thought about them, not cared to examine them. Just input the figures and take them as valid models. No questions asked. Hey, I assumed they were valid models. How can something that official not be valid? I fell into the same trap everyone else did, except in one regard. When it became relevant to examine fat tails, I looked and was astonished and shocked. It was never relevant before. The whole exponential mean was a blatant lie, totally debunked by simple observation. Who needed a sophisticated model when you could just look out the window and see it wasn't raining? But to find that the model is the cause of the exponential myth, that it's the cause of the 100% infected myth, Misquoted as 80% still need to show you that? That beggars belief. I shall be very curious to see when these models came into vogue and who has pushed them, because sure as whatever, people can't have been that stupid forever. But for now, I'm Andrew Mather, a 60-year-old Brit, mathematician, financier, technologist, husband, biker, pilot, healer, whatever. Feel free to get in touch, andrew@peerlessreads.com or andrew@amather.com. Either should get to me.